Hello friends, welcome back in this video session. Today we will be discussing important concept in pharmaceutical analysis, that is primary and secondary standards. So we need to use different kinds of standards in pharmaceutical analysis for various methods of pharmaceutical analysis. So the word standard means a material containing a substance of our interest with known concentration. Because it is present in a pure form, we know the concentration and we can prepare the standard solution from that. So there are different kinds of standards which are used in pharmaceutical analysis. We have working standard, we have reference standard, we have the primary standards, then secondary standards, we have internal standards. So there are different kinds of standards, and in volumetric methods of analysis we mainly use primary and secondary standards. So we will see what these primary and secondary standards are and what are their properties and examples of these primary and secondary standards. So what is the function of these standards, especially the primary and secondary standard? So we need the primary or secondary standard to provide a reference using which we can determine the unknown concentration. So we have to perform the standardization, we have to perform the titrations, so for which we can use some reference, some standard. By using that standard we can compare the concentration, we can determine the concentration of the unknown solution. Then second function is to standardize the volumetric solutions or to prepare the standard solution. So when you want to perform the titrations, usually we take a solution of known concentration in the burette. Okay, so we practically perform these titrations, we prepare the standard solutions using the standards, and then we practically verify whatever concentration we have prepared, let's say 1 molar or 0.1 molar, is it really same molar or it is of different molarity. So we verify practically the concentration of the prepared solution using these standards, because unless and until we do not have any standard we cannot compare the what we have prepared, is it of same concentration or different concentration. Then for preparing the secondary standards, because secondary standards are comparatively less pure with that of primary standard, so we need the standards. So for preparing secondary standards we need a primary standards. Then for calibrating the instrument or calibrating the glassware also we require the standards. Okay, so these are several functions of standards what we need to use in this pharmaceutical analysis, especially with respect to the volumetric methods of analysis where we are interested in performing the different kinds of titrations. Now we'll move to the next point, that is primary standards. So what is primary standard? It is a compound of sufficient purity from which a standard solution can be prepared by direct weighing of quantity of it followed by dilution to give a defined volume of solution. So these are the standards or the substances present in high purity form, and the purity is sufficient. So what is the meaning of sufficient purity? Usually the primary standards are of 99.999% pure. That means they are almost pure, very little amount of impurity is present, and that is known, usually known to us. Okay, so if we have such high purity substances, then we can do the weighing of that substance, and by directly weighing of that substance specified quantity we can prepare a solution. And because it is highly pure solution, we can weigh accurately that substance and we can add or dissolve in a particular solvent. So I know the concentration because it is pure substance, so we refer that as a standard solution. So standard solution is a solution of known concentration which is usually prepared with that of the primary standard substance. So that is the way we can define the primary standard. We can also define this primary standard as it is the substance of known purity. Okay, because we know the purity, usually it has a sufficient purity, we are referring it as 99.99 something, right? So these primary standards are of annular grade. So there are different grades of reagents and solvents which we use in the pharmaceuticals. There are laboratory grade or general grade and then annular grade. So annular grade represent the analytical reagent. So this ANALA represent the analytical and R represents the reagent. So whenever any substance has the label of annular grade, that means it is of high purity substance. Okay, that we can use it as a standard. So it is a substance of known purity whose carefully weighed quantity helps in standardization of unknown solution. So if I want to find out the normality, molarity of the prepared solution, I use these annular grade reagents which we are referring as a primary standard, and we find out the normality or the molarity, or in other terms the concentration of the prepared solution, by doing a standardization. So standardization is a process by which we find out the concentration of unknown solution. Okay, so this is the primary standard. So our primary standard we are considering as a reference. Okay, and with respect to that we are preparing or comparing the secondary standards, and this primary standard are helping us to find out the concentration of unknown solution, then to calibrate the instruments or the glasswares and so on. So the primary standards, as we discussed, they are of high purity or they have a sufficient purity, we are saying it as 99.99 something, right, or more than that. Along with that, the primary standard substances should fulfill certain criteria, or they should have certain properties to consider them as a primary standards. So what are those properties? The first property is the primary standard must be easy to obtain. Okay, so we can easily get those substances, they are preferred one, right? If it is very difficult to obtain or synthesize, then we cannot consider this as a primary standard. So it is easy to obtain, it is easy to purify, and it should be easy to dry, because the primary standards are stored, we are storing, because the whole quantity we are not using at once, we may be using the portions of these quantities, or a little amount we are weighing and then we are using for comparison and so on, right? So during the storage, if at all it is getting absorbing the moisture, right, so we can easily dry those substances. So preferably the substances which can be dried at 110 to 120 degrees Celsius, they are preferred. So this is one of the property of primary standard. So primary standards, they are easy to obtain, they are easy to purify, because we want a pure substance, and they are easy to dry. So during storage, if it has absorb the moisture, right, because during the weighing and all we expose the substance to the atmospheric moisture, so that moisture should be removed, because moisture is nothing but water, and that can also be considered as a impurity. So we can dry before weighing that substance, so that the water will evaporate at 100 and 120 degrees Celsius, and we will get a pure substance which is free from moisture, and to preserve in a pure state. Okay, so because it should be stable, right, and we should be able to preserve that particular substance as a primary standard in its pure form. So this requirement is not usually met by the hydrated substances. For example, you can consider an NaOH. So NaOH is a sodium hydroxide. When you expose it to the atmospheric moisture, it immediately absorbs the moisture and it will undergo a degradation. So those kinds of substances we cannot consider as a primary standard, because they are not fulfilling these conditions. Since it is difficult to remove the surface moisture completely without affecting the partial decomposition for those kind of hydrated substances. So this is a first requirement of primary standard, It should be easy to obtain, easy to purify, easy to dry, and we should able to preserve that in a pure state. Second property is the substance should be unaltered in air during weighing. Okay, because we have to take the spatula, and with the spatula we are removing the substance from the container, and then we are putting on the butter paper which is there in the analytical balance or digital balance. So it is exposed to the air, so it should remain unaltered. It should not change its chemical or physical form when it is exposed to the atmospheric air or moisture. So this condition implies that it should not be hygroscopic. Okay, so hygroscopic, again we can take an example of sodium hydroxide, which is highly hygroscopic. Sometimes some substances, they get easily oxidized when they are exposed to air, right? So those substances also we cannot consider it as a primary standard, because when they are exposed to air, and that is very common because we need to expose the substance during the weighing and all, normal weighing. So if it is getting oxidized, then it will change its chemical form and it will not be considered as a primary standard. Or if it is affected by the carbon dioxide, then those substances are changing its chemical nature or the original form, and they cannot be referred or used as a primary standards. The substances should maintain an unchanged composition during the storage. So even if you are not exposing them into atmospheric moisture, but during the storage, if they are undergoing a degradation by some chemical changes or some physical forms are getting changed, then its originality is lost, and then we cannot consider them as a primary standard. So these are the two important things which we need to consider when we are using a substance as a primary standard. So only purity is not a criteria. Purity is one of the criteria. It should have sufficient purity. Along with that, these two things. Additionally, the third is the substance should be capable of being tested for impurities by qualitative and other tests of known sensitivity. Okay, so we should able to uh, identify these substances with the known chemical or any physical test, and the total amount of impurities should not be or generally exceed 0.01 to 0.02%. So only this much amount of impurities we can allow in the chemical substance which fulfilling the other parameters what we have discussed, then only we can consider the substance as a primary standard. Other condition is it should have a high relative molecular mass so that the weighing errors may be negligible, right? So if for example you have the substance whose molecular weight is less than 50, then it is very difficult to prepare its molar concentration or normal concentration. Okay, so if I want to prepare 0.01 molar or 0.01 normal for the substances whose molecular weight is too low, then the weighing errors are bound to happen. Okay, otherwise we have to weigh in a large quantity, and then we have to prepare the solution at higher concentration, and then we need to dilute it further. So those kind of problems should not happen in these cases. Okay, so primary standards, they should have sufficient molecular mass or molecular weight so that weighing errors can be avoided. Next criteria is the properties. Next property is the substance should be readily soluble under the conditions in which it is employed, because these primary standards are usually weighed accurately, and after weighing we dissolve them in a particular solvents. So for what kind of titration or what kind of purpose you are using, so they should be easily soluble, they should be readily soluble in the solvent which you are going to use. Okay, so if I am using a water as a solvent in the titration, so my primary standard should get easily solubilized so that I can prepare a clear standard solution. Next condition is the reaction with the standard solution should be stoichiometric and practically instantaneous. Let's say I am taking a standard solution in the burette, and then I have primary standard in the conical flask, and let's say it is acid base titration. So the reaction between these two, that is a neutralization reaction, so this reaction should be very fast. The reaction should not be slow, because when the reaction is fast, when the reaction is instantaneous, then it will give a very sharp endpoint. There will be a color change which we can easily make out. Okay, so we can find out the equivalence point or the stoichiometric point. So you know, in titration we have two concept. One is a stoichiometry or equivalent point, and the other one is a end point. So this is the point. Stoichiometric point is the point at which the chemical reaction is chemically completed, right? The reaction between these two reactants, titrant and titrate, is chemically completed, and the end point is the point at which the reaction is over and the color change has observed. So that is the end point. Okay, so we should see to that the substance what we are using, it is soluble, and then it should show a stoichiometric and practically instantaneous reaction with that of the substance under the investigation. So these are the ideal properties of primary standards. So those substances who fulfill all those properties what we have discussed, only those substances we can consider as a primary standard. And we know there are only certain substances which can fulfill these criterias, and because of that we have a limited number of substances which we can consider it as a primary standard. Okay, so what these primary standards we have seen, now we will see the examples of primary standards. Now if I want to do the acid base reaction or acid base titration, I need the primary standards which are either acidic or basic in nature, and these can be used for such type of reactions. For example, sodium carbonate Na2CO3 is one of the primary standard for such kind of reactions. Sodium tetraborate Na2B4O7, then potassium hydrogen phthalate, which is very popularly used in these acid base titration. We will be using this for practical also. KHP is a abbreviation or the short form of this potassium hydrogen phthalate, having a formula C8H4O4. Then similarly benzoic acid is also popularly used, having a formula C6H5 and COOH. So these are the examples of primary standards used in acid base reactions. Then when we talk about a complexometric titration where the complex formation reactions are involved, we use a pure metals of zinc, copper, magnesium, manganese and their salts. We can use zinc in the form of granules, then we can use a magnesium, we can use a zinc chloride and calcium chloride. So these are the examples of primary standards for complex formation reaction. Then when we talk about the precipitation titration where precipitation reaction is involved, usually we use a silver nitrate. Silver nitrate have formula AgNO3, but because it is costly, we prefer to use the other standards. So sodium chloride is another primary standard for such reactions. Then potassium chloride KCl and potassium bromide can also be used as a primary standard. So these are the examples. Then when we talk about the redox reactions or oxidation reduction reaction, there we use potassium dichromate K2Cr2O7, then potassium bromate KbRO3, potassium iodate KiO3, sodium oxalate Na2C2O4 and arsenic trioxide As2O3. So these are the primary standards which we will be using or we can use in these kind of titrations, and they possess all those properties what we have discussed so far. Okay, so with the help of these primary standards we can prepare a standard solution. They are present in high purity, so we can have the solution of known concentration, and then that solution we can use it for preparing a primary standard or comparing the other substances or finding the purity of the other substances what we have prepared. Then there is another concept or another kind of standard what we refer it as a secondary standard. So I told you the properties what we have discussed with respect to the primary standard, very few substances possesses or have all those properties. So there is some compromise. There are certain substances which have one of those properties. Okay, all those properties are not there, but one or two properties are missing. Okay, and there is some compromise in the purity of the substance. So those substances we can consider as a secondary standard. Okay, so primary standard substances, there is no compromise in the properties what we have discussed, there is no compromise in the purity what we have discussed. So only 0.01 to 0.02 percentage impurities are tolerable. Okay, but in case of secondary standard, okay, if more than those limits impurities are present, still we can use as a secondary standard. So when the reagent is not available in the pure form, as in the case of most alkali hydroxides, some inorganic acids, then various deliquescent substances, solutions corresponding approximately to the molar strength required are first prepared. Okay, so these are then standardized by titration against a solution of pure substance of known concentration. So usually what we do, we find out the purity of the secondary standard by comparing with that of the primary standard. So preparation of secondary standard depends on, or it requires, the primary standard. Unless and until you do not have a primary standard, you cannot prepare a secondary standard. So in short, we can define the secondary standard as it has less purity than the primary standard, it is less stable and more reactive than primary standard, but its solution remains stable for long period of time. So we can keep the solution for longer period of time because it is stable and it is titrated against the primary standard. So the purity of the secondary standard is determined by comparing with the purity of the primary standard. So we do a chemical reaction of secondary standard with that of the primary standard, and then we do some calculation and we find out the purity or the concentration of the prepared secondary standard solution. Okay, so that's why we consider this as an indirect method which is employed for preparation of solution of most of the acids, sodium hydroxide, potassium hydroxide, because they are hygroscopic, and barium hydroxide, potassium permanganate, it is oxidizable when it comes in presence with the air, then ammonium and potassium thiocyanate and sodium thiosulfate. Okay, so these are the substances which we can refer it as a secondary standards, and they have been titrated against the primary standard. Their purity will be checked and then they can be used as a primary standard. So unless and until you have primary standard, you cannot use it as a secondary standard. So what are the examples of the secondary standards? So when we talk about acid base titration, so HCl, hydrochloric acid, then sulfuric acid, H2SO4, NaOH, which is again a hygroscopic, and then perchloric acid, HCl4. So these are the substances which we can use it as a secondary standard. Okay, so by mistake we have written here a primary standard, so it should be a secondary standard. Then complexometric reaction, we can use EDTA and lead nitrate as a secondary standard. Okay, as a secondary standard. Then similarly, precipitation titration, we can use ammonium thiocyanate, NH4SCN, potassium thiocyanate, KSCN, and mercuric nitrate as the secondary standard for these precipitation titration. Then for oxidation reduction titration, we can use potassium permanganate, sodium thiosulfate, and ammonium ceric sulfate as a secondary standard. Okay, so these are the examples of secondary standards. So in this session we have discussed what are the standards, what are their functions, what is primary standard, definition of primary standard, in which condition the primary standards are used, what are the ideal properties of primary standard, what should be the purity of the primary standard, and the various examples of primary standards. For acid base reaction, what is a primary standard, and so on. Similarly, we have seen what are secondary standards, how they have been prepared and what are the examples of these secondary standards. Okay, so thank you all of you.